subject of my presentation is inventory, preparation and digitization of soil data. Few days ago, my colleagues A.Martinov and Yu.Litvinov spoke about the standards of the exchange of soil information and the structure of distributed database. My speech is a continuation of the presentation of my colleagues. This presentation will describe the experience of development and using distributed database in Russia. One of the important roles in the development is to load it in distributed database new initial information. Information is divided by observation year, scale, data source, object of observation. The main object of soil survey in Russia are soil profile, soil horizon, cartographic unit, representative soil profile. Example of soil observation data, for example, legacy soil map and reports, description soil profile, soil lists and many other. The main objects of agrochemical observation in Russia are soil profile, soil horizon, plots, soil layer, individual and mixed samples. Examples of soil fertility monitoring results: legacy and actual agrochemical map, agrochemical observation reports. Inventory is an important step in loading the database new information. Making a list of data allows you to estimate the total amount of soil data and quality of data. In the example, you see a list of soil maps for farms in the administrative region of Russia. Preparation of soil data depends on the type of object. For legacy soil map, scanning paper legacy maps, processing in graphic editors, semantic analysis of soil names, disaggregation and harmonization of semantic data, georeferencing legacy maps, vectorization, entering attribute data, and verification digital map. File format load in database shape. For description of soil profiles, scanning paper legacy maps and soil observation reports, processing in graphic editors, georeferencing legacy maps, vectorization, position soil profiles, entering data into the input form, verification data. File format load in database XML. For agrochemical survey reports, entering soil properties into the input form and or entering agrochemical survey data in the table file within a standard structure. File format load in database XML, XLS, CSV. Briefly on examples show the features of data preparation. Disaggregation is division of the name soil into structural components, information group. The composition of information groups and their number depends on the regional characteristics of the soil. The possibility of translation from nominal and ordinal scale to quantitative. Georeferencing of soil maps is performed using a set of orthophotos with different priorities. Vectorization is performed on the basis of any geographical informational system, for example, ArcGIS. A feature of vectorization is the use of ready-made list of classifier and the display of soil combination as a set of layers with the sample geometry but different attribute information. Data describing the soil profile to contain the following group of information: geographical position, describe location of profile, soil classification name, soil properties, year of observation. For entering information using a special input form, the program works offline and allows you make a full description of the soil profile. Data describing mixed soil samples contain information about geographical position, describe location of sampling, soil properties, year of observation. Data can be entered using a table with which standard structure. The data in the table is linked to the database using a set of identifiers, such as the sample code in the database and the year of the observation. My colleagues will tell you more about the use of data for solving practical problems. Please.
So, when information already collected, we have three main directions how we can use it. And first of all, I want to say a few words about educational, because we are working in Moscow State University, and education is a very important part of our work. We want to make soil data center useful not only for scientists and farmers, but also for students and even pupils. And Moscow State University every year organized Olympic of subjects such ecology and soil science, and a lot of pupils take part in this Olympic, and winners of this Olympic get a lot of benefits and can enter university without any exam. But we have a problem that there is no subject like soil science in school program. So pupils have a very hard work to prepare for this Olympic. And so we make something like electronic handbook of fundamental soil science and geography of soil. And it's based on soil museums of all Russian soil museums. And now we show you how it looks like on our website. You can see the list of main soil museums of Russia. Some of them have websites, some of them have a lot of information. It looks like a virtual museum. For example, it's a virtual museum of soils of Tomsk State University. This website have a lot of photos of soil profile, and pupils can get a lot of information about soil types of all territory of Russia. It's very useful information for them. Next museum is based on Rostov State University. It's a Zakharov Museum, and this museum looks like a handbook about soil science and geography of soil. Pupils can find a lot of information about structure of soil profiles, of soil properties, and other very useful information. You can see that this museum have a lot of photos and instruction and describe many soil properties. So about scientific, I can say that Moscow State University is first of all a lot of fundamental investigation, and a lot of them keep in touch with our soil data center. For example, soil diversity study and conservation, National Atlas of Soil, Soil of Nature Reserves and National Parks, project about Red Data Book of Russian soils, and of course Global Soil Organic Carbon Map. So you already heard a lot of words about Global Soil Organic Carbon Map, but I just want to say a few words about our national SOC map, and we want to show you our application, which show how many information we can get to calculation this our national map.
Okay.
So Alexander, show.
Let's go back to the information system soil geographic database of Russia, the website. Here we have the page divided to the global organic carbon map. Russia has very unique experience in this area because of the huge territory of the country, and as a result of this work we created soil organic carbon map of Russia, as well as the map of the relative error for the preparation of the map. And as you probably understand, this work was conducted with many scientific groups and organizations. And on our information system website, we can determine which exact group, scientific group or organization collected and store the data for the specific region. For example, we may click and see the latitude, longitude for any area. Then we click Show Table button, and the data are loaded here. So, as we can see, the soil data for this specific region are collected by, in this case, by Soil Department of Lomonosov Moscow State University and Agro Center Rostovsky. Now, another one thing I would like to mention that we can inspect this data and to contact this organization, any organization, to get these specific soil data. Next, I would like to show you another application which is called calculation of normative yield of grain crops. This service allows us to calculate the normative yield for any field for which we have the corresponding data. It works like this. So we can click on any field, then click the Get Data button, wait a little bit, and here, as you see, we loaded a data for this specific field. the field is divided according to the soil on this field to several subparts, subsoils. These parts are highlighted by different colors. Each of these parts have its own normative yield for crops. It is indicated here for every specific area, and moreover we can see the data of the subfield in more detail by clicking here. Here we can see the type of soil, subtype of soil, some soil specific data, and a farmer who owns this territory. And these data can be used to calculate taxes which farmer should pay for this field. Next, let's go to the third application, which is called calculation the need of mineral fertilizers for target yields. This program can be used to calculate how many nutrients should be added to a specific field to get the target result, the target yield for a crop. It works like this. We can put the marker on any field, click the Get Data button, and the data about the field are loaded. Here we can see the type of humus, phosphorus, potassium, and other data about the field. But what is more important, we can select the desired target, for example, 30 centers per hectare, and we can choose the culture the farmer is going to get here. For example, the bean culture, peas. And right now we see the data, we see how much phosphorus nutrients or potassium nutrients we should add to this field per year. And that's how it works. So basically it's what we wanted to show you. This is our website of information system soil geographic database. This project is still going on. We are going to work on him the next year and after. It has English version, but we yet didn't translate all the pages, but we are working on this and we will continue this work. So this is basically what we wanted to show you, and you may ask our questions if you want. Thanks for your attention.